1.
Okay, so we're talking about prime factorization and the factor tree today. So I'm going to go through and repeat what we did in class today. So prime factorization is expressing or showing a composite number as a product. And remember, product is the answer to a multiplication problem. Okay, so it's expressing or showing a composite number as a product of its prime factors. Okay, how do we determine the prime factorization of a composite number? Well, we use a factor tree, and that is a method or a way to organize and help you find the prime factorization of a number. The rule here is you cannot use the number 1 when trying to determine those prime numbers, because if I used, here's my example, 24. If I use 24 times 1, I'm not going anywhere. I haven't gotten down to any prime numbers. So you can use any factor that is not 24. So those of you who know your fact families and have mastered your multiplication problems, you would know 2 factors of 24, which would mean what 2 numbers would multiply together make 24. Okay, so 6 times 4 is the first thing that comes to my mind. Now, if you have not mastered your multiplication facts, you can use your multiplication chart. But again, I can't stress enough. You guys have, those of you who haven't mastered your multiplication facts, and I've been saying this all year, it's going to make your life in math through the rest of your school career so much easier. It's such a great investment of your time. Okay. So anyhow, if you don't know your math facts, look at your multiplication chart and just find the number 24. Okay, here's the number 24. What are 2 factors that equal 24? The number 6, and I look over here. Okay, I just happened to pull up the same one, right? 6 and 4. So my factor tree, I start at the top, 24. So 6 times 4 is 24. Now, neither of these numbers are prime. And again, you can use your math notebook to review your prime numbers. You guys have your prime number chart in your math notebook on page number 54. So if I were to look at the number 6 and the number 4, I know those are not prime numbers because they are divisible by 2, right? If I can divide even numbers by 2, these are not prime numbers. So I have to keep going. The 6, what 2 numbers will multiply together make 6. Okay, and I know 3 and 2 are those 2 numbers. Again, I can't use 6 times 1 because I cannot use 1 here. Now, 3 and 2 are prime numbers, so I am going to circle them. I have gotten as far as I can here. Now I'm going to go over to my 4, and I'm going to find 2 factors that make 4. And again, the only 2 numbers would be 2 times 2, because again, we can't use the number 1. Okay? Now, 2 again is a prime number, so I've circled them. So what is the prime factorization of 24? If I were to rewrite this, I would say the prime factorization is 3 times 2 times 2 times 2. Okay, another way I can say that is I could say 3 times 2 cubed, or to the 3rd power. Remember when we were talking about exponents? 2 multiplied by itself 3 times, right? This means the same thing. It's the same expression. But there you go. There's the prime factorization. Now, I want to prove a point here. 24. I'm going to use different factors, and I'm going to see if I end up with the same prime numbers or not. So 24 again. And I know 12 times 2 is 24. So I'm going to use that. Now immediately, I can circle this 2 because 2 is a prime number. Now I'm going to go to my 12. 12 is an even number, and I know I can divide it by 2. So 2 times 6 is 12. There's 2, which is prime. And then my 6 is an even number. I know I can again divide it by 2. 2 times 3 is 6. And I'm going to circle 2 and 3 because they're prime. So if I were to look at these again, 24 is equal to, and then I'm just going to look at all of my numbers that I've circled because I've identified them as prime. So here's the 3. How many 2's do I have? 1, 2, 3. 2 times 2 times 2. Or I could also say 3 times 2 cubed, or to the third power. Okay, so what do we notice? We have the same answer. So it doesn't matter what factors you begin with, you're always going to end up with the exact same prime numbers. Okay,